In this video, we're going to take the Lewis structures that we did in the last video and just do a little bit more with them. The last part of Lewis structures that you'll be responsible for in this class is something called an expanded octet. Only elements in period 3 or higher can have expanded octets. So if it's in period 1 or 2, it cannot have it because those elements do not have d orbitals. So elements with empty d orbitals, so our non-metals in period 3 or higher, fit that bill, can fit more than 8 electrons. There are two different types of expanded octets. These two examples will show you those two types. So the way you do an expanded octet is you figure out the valence electrons just like you normally would. So for sulfur, we have 6 valence electrons, and we have 1 sulfur. And fluorine has 7 valence electrons, and we have 6 fluorines. So we do out that math, and we get 48 valence electrons. Our central atom, of course, is going to be sulfur, because fluorine can never be the central atom. And here's the first type. The first type of expanded octet is when you have more than 4 terminal atoms. So we're not going to have a fluorine that is bonded to another fluorine because fluorine already has 7 valence electrons. So instead, so it can't have 2 bonds. Instead, what you'll do is put all 6 of the fluorines around the sulfur. You then do your Lewis structure exactly the same way. So subtract 12, you have 36 left. Put 3 pairs around each terminal atom because none of them are hydrogen. And then this is your final structure. Every terminal atom should still have 8 in an expanded octet, but the central atom can have more than 8. It's expanded. Okay? It's not a question of always knowing when this shows up, it's just knowing that it can. So when you're looking at something you can't quite figure out how to do it, consider an expanded octet. That might help. So now let's talk about XeF4, which is the other type of expanded octet. Xe has 8 valence electrons, and you might be thinking, wait, isn't it a noble gas? Doesn't it not bond? Well, here you go. Xe can sometimes bond. We have one of them here, fluorine 7. So that gives us a total of, I'll put it over here, 36 again. Fluorine still can't be the central atom, so Xe will be the central atom. We then put all of our fluorines around. And then we do our 3 pairs. But we still have 4 left. This is the second kind of expanded octet. When you have satisfied the octet rule for all of the elements, but you still have some left over, you still follow the same Lewis structure rules. You know that if you have electrons left at the end, you put them on the central atom. So you're going to do the same thing, and you will pair them. Now, Xe, again, is expanded. All of the terminal atoms still follow the octet rule, and Xe has more than 8 valence electrons, and that's okay because Xe has an expanded octet. And so that's it. That's all we're going to do in this video is just those expanded octets, and we'll do practice in class.